So in this lesson, which happens to be, let's change the lesson number, this is 2-5, we are going to talk about how to solve systems with 3 variables. So all this is depicting for you is what one solution of 3 planes, an x, y, and z plane, look like when they intersect. And so they intersect right here at one nice, happy, neat point. So they could also look like, so this would be one solution. Then there could be infinitely many solutions. And you see that over here where they would intersect in a line. So the line would give you infinitely many solutions. And then these are 3 examples of no solution where you've got 2 planes intersecting here in a line, 2 planes intersecting here in a line, but all 3 planes do not intersect in the same place. So that would be considered no solution for all 3 planes. And again, this looks like a triangle here, but you've got 2 planes here intersecting in a line, 2 planes intersecting in a line, 2 planes intersecting in a line. So again, all 3 don't have one thing in common, or they could all be parallel to each other. Then the other thing that I want you to highlight would be this right here. So these are the procedures for solving a system that has 3 unknowns. Become familiar with it. If you get stuck, come back to this list and see if you did it. But basically, you're going to have 3 equations with 3 unknowns. You're going to take 2 equations at a time, and you're going to eliminate one of the 3 variables. Then you'll take a different 2 set of equations and eliminate that same variable in those 2, and then you'll create 2 equations with 2 unknowns, and you're back to what we did the other day, solving a system with 2 unknowns. So let's see how this goes. We're going to start with the first example. Pardon me, I just lost my voice. All right, let me make this bigger. Okay. Let me straighten it out. So these require a lot of space. So I want to get rid of as much of that other problem as possible. There we go. So it would be beneficial to you if you would number your equations. So I'm going to number this equation 1, 2, and 3. And then number your steps. So I'm also going to list my steps out as A, B, C, D, etc. And in addition to that, I'll let you know which equations I'm using. So here we have to decide we want to eliminate the x's, the y's, or the z's. So if we choose 2 equations, like let's say I choose equation 1 and 2, if I just add them together just the way they are, the y's are going to cancel out. And then if I select equations 2 and 3, if I add them just the way they are, again the y's are going to cancel out. So I think I'm going to try to get rid of my y's in all 3 of these equations and create 2 new equations. So step A, I'm going to use equation 1 and equation 2. So equation 1, I don't have to do anything to it. And equation 2, I don't have to do anything to that. Then I'm just going to add them exactly as you see them, and the y's here are going to cancel. X plus x is 2x. Z plus 3z is 4z. And -1 and -3 is -4. So this now creates equation, not 3, because we've already used that. So this is equation 4. So then part B, now you have to pick 2 different equations. So since we chose 1 and 2 before, I'm going to choose 2 and 3. So we're going to use those equations, 2 and 3. And again, I don't have to do anything in order for the y's to cancel. So I've got x plus y plus 3z equals -3 And I have for equation 3, 2x minus y plus 2z equals 0. And if I add those exactly as I see them, the y's cancel. X plus 2x is 3x. 3z plus 2z is 5z equals negative 3 plus 0 is negative 3. So now I've created a fifth equation. So now I have two equations with only two unknowns, x and z. So I can go ahead and do what we did a couple of videos ago and solve a system of two equations with two unknowns. And so my x is 2 and 3. So if I wanted to eliminate my x's, I could make them into 6's. One would have to be positive, one would have to be negative. My z's are 4z and 5z. And so if I wanted to eliminate my z's, I'd have to make them into 20. So I think I'm going to eliminate the x's. So I'm going to go ahead and multiply equation 4 by, let's see which one I'm going to make negative. I'm going to multiply this one by negative 3. And I'm going to multiply this equation by positive 2. So part C, equation 4, and then this will be equation 5. So equation 4, when I multiply the negative 3 through, I get negative 6x minus 12z equals, and don't forget to multiply to your constant, positive 12. Equation 5, when I multiply the 2 through, I get 6x plus 10z equals negative 6. Now when I add those, my x's cancel, and I get a negative 2z equals positive 6 divided by negative 2, and we get z equaling negative 3. So now I have one of my variables, and just like we did with a system of two equations, once you had one of the variables, you can plug it into either one of these equations. So plug it in here for the z, and you can solve for x. So I think I'm going to plug it in here to this second equation, number 5. So part D, I'm going to use equation 5, and we're going to plug in for z. So 6x plus 10 times z, which is negative 3, equals negative 6. So 6x minus 30 equals negative 6. Add 30. And I get 6x equals 24. Divide by 6. And x is equal to positive 4. So now I have two of my variables. I've got z and x. So now I can take both of these and go all the way to one of my original equations and plug in the z and the x and solve for the y. So as I look at these equations, I'm probably going to plug, it doesn't really matter. I'm going to plug into, I'll plug into the first one. So part E, I'm going to use equation 1, and I'm going to plug in my value. So instead of x, I'm putting in a 4 minus y. And then instead of z, I'm putting in a minus 3 equals negative 1. So 4 minus 3 is 1 minus y equals a negative 1. Subtract 1. You get a negative y equals -2, and divide by -1 or multiply by -1, and you get y equals a +2. And so the last part is to write your answer as a triple ordered pair. You cannot leave your answer this way. And so our x value is 4, our y value is 2, and our z value is -3. So there's your solution. So you could check this. You could go into each of these three equations and plug in 4 for x, 2 for y, and -3 for z, and see if you get these values. I'm not going to take the time on the video to do that, but if you wanted to check, you could. So then we're going to go on to example 2. So moving this up, example 2. So just going to go through the same process again, just with different equations. So I'm going to start renumbering my equations. And so we're going to select two equations with which, or we're going to try to decide which variable we want to eliminate. So if I were to add the equations this time, you can see that the -2y and this +2y would eliminate. So again, I think I'm going to choose to eliminate the y's. You don't have to, but that's what I think I'm going to do. So I'm going to start with equation 1 and 3. So x minus 2y plus 3z is equal to 12, and 2x plus 2y minus z is equal to 4. So if I add those, my y terms cancel. X plus 2x is 3x. 3z minus z is positive 2z. And 12 and 4 is equal to 16. Whoops, that looks like 116. Let's try that again. Equals 16. So that gives me equation 4. And then we're going to have to do this all over again, so I can try 2 more equations. So if I want to get rid of my y, I have not tried equation 2 yet, so we need to use that. So I'm best off combining it with equation 3, and I would just need to multiply equation 2 by a +2 to make this y here a -2, because it already has the negative. So if I multiply it by a +2, I'll have a -2y, which will cancel with the 2y. So we are going to use equation 2 and 3. So 2 times 2x is 4x. 2 times -y, -2y, equals 2 times 5 is 10. And then we're not changing equation 3, so 2x plus 2y, and of course I forgot my z up there. I'm already one step ahead of myself. Let's go back. So 2 times -2z is -4z. I don't know how I skipped that. And then 2 times 5 is 10. All right, back to equation 3. So then we have a minus z equals 4. And now I can add these together. Now my y's will cancel. 4x and 2x is 6x. -4z, -z is -5z. 10 and 4 is 14. So now we've created equation 5. So then part C, I need to take these two equations and decide whether I'm going to eliminate x's or the z's. If I eliminate x's, I would make them both into 6. So I just need to multiply this equation by -2. But if I eliminate the z's, I would have to make them both into 10, and that would require me, now I do have a plus minus, but that would require me to multiply this equation by 5 to make that into 10, and this equation by 2 to make that into -10. So since it's less work to change this one, I'm going to eliminate my x's. So let's multiply this equation here by 2 in order to get what we need. So I'm going to use equation 4 and equation 5, but I'm multiplying the 2 to equation 4. So 2 times 3x is 6x. 2 times 2z is positive 4z equals 2 times 16 is 32. Then we're not changing equation 5, so, oh, clearly, what's wrong? I don't have opposite signs here. So instead of multiplying by 2, I should multiply by negative 2. So that's going to create a negative 6x here. And then instead of this being positive here, which it will no longer let me erase it, yippee skippy. So this is going to end up being a minus here, so that's a big old minus. And of course the 32 is a negative. So now I can continue. So I've got a 6x minus 5z equals 14. So now I can add. Now the x's will cancel. So I caught it a little early. A negative 4z and a negative 5z is a negative 9z equals negative 32 and positive 14 is negative 18. And then divide by negative 9. You get z equals positive 2. So now we have one of our values, so we're going to plug that positive 2 in for z, either in this equation here or in this equation here. This one doesn't have any negatives, so I'm going to choose to plug it into equation 4. So it's a really sad looking D, but it's going to stay. All right, so I have 3x plus 2z, and instead of z, I'm going to put in a 2, and then equals 16. So 3x plus 4 equals 16. Subtract 4 from both sides. You get 3x is equal to 12. Divide by 3, x is 4. So now I have 2 of my 3 unknowns. I can go all the way back to the original and plug in the x and the z to find the y. So this is the only equation where the x and the z are both positive, which makes it the easiest to plug into. So I think I'm going to plug into equation 1. So part E, and then I'm going to plug into equation 1. So instead of x, I'm going to put in a 4 minus 2y plus 3 times my z value, which is 2, equals 12. So 4 minus 2y plus 6 equals 12. The 4 and the 6 is 10 minus 2y equals 12. Subtract 10 from both sides. You get negative 2y equals 2. Divide by negative 2. And you get y is equal to negative 1. So now I have all of my values. So part F, you're going to write your triple order pair. So my x value is 4, y value is negative 1, and z is 2. And that's it. And it's just a long problem, but it's the same process as what we did before. Let's try it again. So we have one more example, and then we'll get to some word problems. So again, I want to make this as big as possible. Here we go. Okay. So for example 3, once again, I'm going to start off with numbering my equations. Okay. So there is, once again, a y, so it seems to be a pattern, but if I add these two together, I could easily eliminate my y's. I could also eliminate my z's. So let's go ahead and do this because an interesting thing is going to occur. So let's watch what happens when I put together equation 1 and 3. Okay, so I am going to not do anything to equation 1. And I'm not going to do anything to equation 3. So when I add these two together, not only do the y's cancel, but the z's cancel, and that leaves me with x plus 2x, which is 3x, equals, and negative 4 and 10 is 6, and if I divide both sides by 2, I get x is equal to 2. So technically this is equation 4, but I now know my x. So I could plug in my x into both of these equations here, and well, that's not going to do me any good because these are going to cancel out. So let's go ahead and plug my x into probably one of the different equations. So we could plug it into here and see what that gives us. So let's go ahead and try that. So let's do this. This is a different process for this particular one, only because we got x right away. So if I plug x into, let's do 1 and 2. Let's see what that does for us. So if I've got, I'm just trying to think ahead. So I've got a 2 in for my x. Well, let's go ahead and put in what equations I'm using so you can see that. So I'm going to use equation 1 and 2 and 2. But I'm also plugging in my x value of 2 into equation 1 and 2 at the same time. I just want to see what I have first. So I'm going to plug in 2 for x, and then I get a minus 2y plus z equals negative 4. And then in equation 2, I have a negative 4, and instead of x, I'm plugging in 2, and then I have plus y minus 2z equals 1. So rewrite what I've got. So I have a 2 here, then I'm going to subtract 2 from this side, subtract 2 from this side. That's going to give me a negative 6 over there. So I get negative 2y. I apologize if you can hear snoring. It is Jojo the pug. Do you hear that? Wait. Now she's not. There she goes. That's the pug. Sorry. She has to be on the lap. All right. So I get negative 2y plus z equals negative 6. Then this is going to give me negative 8. So I'm going to add 8 to this side, add 8 to this side, which will give me 9 over here. So I have y minus 2z is equal to 9. Now, add what I have. Oh, I can't add this because if I try to add this, nothing cancels. So I have to figure out, what am I going to do? Am I going to get rid of my y's or get rid of my z's? I can multiply this whole equation by positive 2. So I turn that into a 2 and it'll cancel out with a z. Or I can multiply this by positive 2, which will cancel out the y's. And it really doesn't matter which one you choose to do. So I think I'm going to multiply this equation by positive 2. So then you get negative 2y plus z is equal to negative 6. Then multiply your 2 through, positive 2y minus 4z is equal to 18. Now add, your y's cancel. Positive 1 and negative 4 is negative 3z. Negative 6 and 18 is a positive 12. And so if you divide by negative 3, z is going to equal negative 4. And so now I know 2 of my values. I can then plug those 2 values into one of these equations here and solve for y. So I think I'm going to plug it into equation 1. So step C, I'm going to use equation 1. Instead of x, I'm replacing it with 2 minus 2y. And instead of z, I'm replacing it with a minus 4 equals negative 4. So combining your like terms, 2 and negative 4 is going to give me a negative 2, and I already brought down the negative 2y, equals negative 4. Then add 2. And so you get a negative 2y is equal to negative 2. When you divide by negative 2, you are going to get y equals a positive 1. And so now I have all 3. So I can write my triple ordered pair. So x is 2, y is 1, and z is negative 4. That's it. So let's look at some word problems now. So making this a smidgy smaller so we can read the whole word problem. If I can get that in here. Alright, so let's make it a smidgy bit bigger. Okay, so you can see the majority of it. So you manage a clothing store and budget $5,400 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. Suppose you want to have the same number of t-shirts as polo shirts. How many of each shirt would you buy? So I think I will use some capital letters here to represent T for t-shirts, P for polo, and R for rugby. Oh, Joey. All right, so I'm going to define my variables. So let T equal number of t-shirts. And then P will equal number of polo shirts. And then R will equal number of rugby shirts. Yep, that looks like one word. It's not. All right, then we're going to write our system of equations. So here's your system. You're going to have to reword or reread what you see above, and we're going to highlight what's important. So you manage a clothing store and you budget $5,400, so that's a restriction. And then you restock 200 shirts. So let's just start there. How do you spend up to that $5,400? Well, you pay $12 for each polo, you can buy t-shirts for $12, polos for $24, and rugby shirts for $36. So you're going to multiply that to each of those numbers, and it should add up to $5,400. So 12 times T plus 24 times P plus 36 times R, that should all add up to $5,400. Then your other restriction is the $200 shirts. So that means that the number of these shirts have to add up to 200 because you're ordering 200 shirts. So you've got T plus P plus R is equal to 200. Well, you have 3 unknowns, so you need 3 equations. So what else in here is going to help you with your restrictions? So as you read along, it says, suppose you want to have the same number of t-shirts as polo shirts. How many of each shirt would you buy? So if I want the same number of t-shirts as polo shirts, t-shirts ought to equal polo. So T is going to equal P. So we're going to now solve, and you have a couple of options. When you solve, you could, because T is equal to P, you could go up here and replace every P with a T, and that'll give you 2 unknowns, 2 equations and 2 unknowns, or every T with a P, and same thing. So I think that's what we're going to do. But let me number our equations first. So this is equation 1, equation 2, and equation 3. So part A, let's substitute into equation 1 and 2. So we're going to use 1 and 2. And we're going to actually substitute in P for the T. So I have 12. Instead of T, I'm putting P. And then I have plus 24, P, and then plus 36R. And then for number 2, I'm replacing T with P, plus P, plus R. Oh, I forgot to equals. Equals up here 5,400. And then this one equals 200. So let's rewrite the system and combine our like terms. All right, so hopefully I will have fixed the awful volumes because I don't know, the microphone's been messed up here a little bit. Okay, so I've got 12P and 24P. That's going to give me 36P. Plus 36R is equal to 5,400. Then I have for the second equation, P plus P is 2P plus R is equal to 200. So I've got 2 equations with 2 unknowns, and I have to figure out, do I want to eliminate P's or R's? So I could multiply this entire equation by 18 to make, or negative 18 to make it into a negative 36, or by a negative 36 to eliminate this. So I think I'd rather multiply by a negative 18 because it's smaller. And so I get 36P plus 36R is equal to 5,400. And then negative 36P minus 18R is equal to negative 3,600. So add that together. Your P's cancel. And I get 18R is equal to how about 1,800? And then if you divide by 18, you get R is equal to 100. So if R is equal to 100, let's just reason our way through the solution. If R is 100 and T is equal to P, and we're only ordering 200 t-shirts, that leaves 100 t-shirts left over that gets split between T and P. So T would have to be 50 and P would have to be 50. So therefore, you would buy 50 t-shirts 50 polo shirts and 100 rugby shirts. Whoops, spelled wrong. So your goal is to take the story, or take the math out of the story, and just do the math. So let's do another word problem. So this is our last problem. Let me try to make it a little bigger. Fortunately for you, they have defined, let me erase the line I just inadvertently drew. They have defined the variables for you. Okay, this way I can see everything and you can see everything. Okay, so a company placed $500,000 in 3 different accounts. So here's the 3 accounts. It placed one account in short-term notes paying 5.5% per year. Then, let's see, it placed one account in short-term notes paying 5.5% per year, 3 times as much in government bonds paying 7% per year, and the rest in utility bonds paying 4.5% each. The income after 1 year was $31,000. The question is, how much money was placed into each account? So we are going to have to do a little bit of thinking here because we've got to come up with our system. So I want you to reread it and look for things that are like restrictions or things that we can do something to add to something else. And something that really stands out is that the company placed $500,000 in 3 different accounts. So that means that this account plus this account plus this account has to add up to $500,000. So let's go ahead and write our system. Whoops. So our first equation is going to be the amount X plus the amount Y plus the amount Z. The money in those accounts have to add up to $500,000. Then it goes on to say that it placed one account in short-term notes paying 5.5% per year. So let's write that over here. This is 5.5%, which is equal to its decimal equivalency of 0.055. We're going to need that. And then 3 times as much in government bonds paying 7% per year. So this is 7%, which equals 0.007. I don't know why I just put 0.07. Then, finally, the rest in utility bonds paying 4.5% per year. So move your decimal 2 places and you get 0.045. Okay, but here's the key. Let's get my highlighter. The income after 1 year was $31,000. So how do you get income on investment amounts? You're going to take the amount and multiply it by the investment rate. So we would have, for the short-term notes, you're going to take, let's do 0.055 times X, and you're going to add to that the rate for the government bonds, 0.07 times the amount you have in the government bonds. You're going to add to that 0.045 times the amount you have in the utility bonds, and that should give you a total income of $31,000. Now we only have two equations and two unknowns. We need a third equation. Now, buried deep in here is 3 times as much. So it said it placed one account in short-term notes, paying this, 3 times as much in government bonds. The question is 3 times as much as what? It's a little vague, but it's 3 times as much as the short-term notes. So if the short-term notes are X and the long-term notes is Y, and we have 3 times as much in the government bonds as this, if I knew what the short-term notes amount would be, I'd multiply it by 3 to get what the government bonds were. So my third equation is going to be 3 times X is equal to Y. So I am going to number my equations. So this is 1, 2, and 3. So what I can do is for every Y, I could replace it with 3x. So everywhere I see a y, here and here, I can replace it with 3x. So let's try that and see what happens. So part A, I'm going to take equation 1 and equation 2 and replace every y with a 3x. So I've got x plus, instead of the y, I'm replacing it with 3x plus z, is equal to 500,000. Then for equation 2, I have 0.055 x plus 0.07, and instead of y, I'm replacing it with 3x, and then plus 0.045, z is equal to 31,000. Let's see what we have. So let's rewrite it. So I've got x, no, that's wrong. I've got x plus 3x, which gives us 4x's. So I have 4x's, and then plus z is equal to 500,000. Then, if I take this, I'm going to take 0.07, and I'm going to multiply it by 3, and that gives me 0.21 right here. I'm going to add 0.055 to that, and that gives me 0.265. So I get 0.265 x, and then plus 0.045 z is equal to 31,000. All right, so we want to eliminate x's or z's. Since z has a coefficient of 1, right here it would be much easier if I multiplied this entire equation by negative 0.045. It's just the easiest way to figure out what to do. So negative 0.045, thank goodness for calculators. So we're going to rewrite what we have. So 0.045 times 4. So we get a negative 0.18 minus 0.045 z is equal to 0.045 times 500,000. So I get negative 22,500. Then we're going to add to that plus 31,000. So now when I add this together, the z's cancel. And so then I just need to take the 0.265 and subtract from that the 0.18, and I get, whoops, I want a black for that, so 0.085 x equals, then 31,000 minus 22,500 is going to give us 8,500, and then divide by 0.085, and we get x equals 100,000. Well, the great thing about that is that if I multiply x by 3, right, if I multiply x by 3, I have y. So 3 times 1,000 would mean that y, 3 times 100,000 would be 300,000, and I know that I only have 500 total in the account, so 300 plus 100 is 400. That leaves for z 100,000. So, therefore, all right, so let me use blue. Therefore, you would have $100,000 in short-term notes and $300,000 in government bonds, and $100,000 in utility bonds. And that's it. If you have any questions on your homework, don't hesitate to ask.